Earth's last magnetic pole flip happened much more slowly than we thought. This is by Devin Neild, Science Alert. According to new research, it suggests Earth's most recent magnetic field reversal took longer to complete than previously thought, around 22,000 years in total. Figuring out why this peculiar flip was so drawn out will let us better understand this mysterious process, maybe even help us to prepare for this. It's a fact geologists know about our planet. Every few 100,000 years or so, the Earth's magnetic field quite literally flips. So the magnetic north is at the South Pole and vice versa. Well, we know that recently, the past few years, it's been moving at about 34 miles a year from Canada towards Siberia. That's pretty fast. They even had to adjust the GPS for the true magnetic north. So every few 100,000 years, magnetic north is at the South Pole and vice versa. It's important to establish the timings of these reversals so we know how much of a window we have to potentially adapt for the next one, if that's at all possible. With so many modern-day systems like GPS reliant on knowing north from south, a flip could easily cause chaos one day. Earth's magnetic field is created by the planet's liquid iron outer core spinning around its solid inner core. Charting magnetic field reversals back through time is not easy, but clues can be found in ocean sediments and lava flows that lock in the direction and the strength of the magnetic field at the time they emerged. Quote, lava flows are ideal recorders of the magnetic field, unquote. This is what geologist Brad Singer, University of Wisconsin-Madison says. He explains they have a lot of iron-bearing minerals, and when they cool, they lock in the direction of the field. But it's a spotty record. No volcanoes are erupting continuously, so we're relying on careful fieldwork to identify the right records. Singer and his colleagues looked at lava flows from Chile, Tahiti, Hawaii, the Caribbean, and the Canary Islands, looking at the timing of the most recent reversal. Named the Matuyama-Brunnes reversal, after the scientists who discovered magnetic field flips, it happened about 770,000 to 780,000 years ago. That timing suggests we're overdue for a reversal right now, although we may just be in a period of instability that does not result in a full flip, that is, something that's happened before as well. There's currently some debate over how long the next reversal will last. Based on the lava rock records, the researchers found that the main part of the Matuyama-Brunnes event lasted 4,000 years, but was preceded by 18,000 years of instability and excursions, those temporary partial reversals. The findings were backed up by an analysis of rocks from the ocean floor, a more continuous but less precise record of Earth's magnetic field. This time frame is longer than the previous estimates and hints that we won't suddenly be surprised by a relatively quick flip. We still don't know for sure how long the next flip might last, or exactly when it's coming, but we do now have the wealth of extra data that helps scientists make their best estimations. If we're in for another Matuyama-Brunnes reversal, this study suggests it's going to last for many generations. When the time does come, our planet's magnetic field is going to be weaker and more complicated than it is now, so it's vital that we're prepared. Quote, reversals are generated in the deepest part of Earth's interior, but the effects manifest themselves all the way through the Earth, and especially at the Earth's surface and in the atmosphere, says Singer. He says, unless you have a complete, accurate, and high-resolution record of what a field reversal really is like at the surface of the Earth, it's difficult to even discuss what the mechanics of generating a reversal are. This was published in Science Advances. Now, the magnetic pole flip is also known as the geomagnetic reversal. a change in the planet's magnetic field, such as the positions magnetic north, magnetic south, are interchanged, not to be confused with geographic north and geographic south. The Earth's field has alternated between periods of normal polarity, in which the predominant direction of the field was the same as the present direction, and reverse polarity, in which it was the opposite. These periods are called crons. Reversal occurrences are statistically random. There have been 183 reversals over the last 83 million years. The latest, the Brunus-Matuyama reversal, about 780,000 years ago, with widely varying estimates of how quickly it happened. Other sources estimate that the time it takes for a reversal to complete is an average about 7,000 years for the four most recent reversals. Clement in 2004 suggested that this duration is dependent on latitude, with shorter durations at low latitudes and longer durations at mid and high latitudes. Although variable, the duration of a full reversal is typically between 2,000 and 12,000 years, which is 1 to 2 orders of magnitude less than the duration of magnetic crons. Although there have been periods in which the field reversal globally, such as the LeCamp excursion, for several hundred years, these events are classified as excursions rather than full geomagnetic reversals. Stable polarity crons often show large, rapid directional excursions, which occur more often than reversals, and could be seen as failed reversals. During such an excursion, the field reverses in the liquid outer core, but not in the solid inner core. Diffusions in the liquid outer core is on timescales of 500 years or less, while that of the solid inner core is much longer, around 3,000 years. Character of the transitions and duration. Most estimates for the duration polarity transition between 1,000 and 10,000 years, but some estimates are as quick as a human lifetime. So it's not slow, it could be as quick as a human lifetime. And now, who says this? This is reading from Wikipedia. Note 22 is Freva and Camp found in 1995 new evidence for extraordinary rapid change of the geomagnetic field during a reversal, published in Nature magazine. So you can see it could be even in as fast as a human lifetime. Studies of 15-million-year-old lava flows on Steens Mountain, Oregon, indicate that the Earth's magnetic field is capable of shifting at a rate of up to 6 degrees per day. This was initially met with skepticism from paleomagnetists, even if changes occurred that quickly in the core. The mantle, which is a semiconductor, is thought to remove variations with periods less than a few months. A variety of possible rock magnetic mechanisms were proposed that would lead to a false signal, but paleomagnetic studies of other sections from the same region, the Oregon Plateau flood basalts, give consistent results. It appeared that the reversal to normal polarity transition that marks the end of the Cron C5CR, which was 16.7 million years ago, contains a series of reversals and excursions. In addition, geologists Scott Bogue of Occidental College and Jonathan Glenn of U.S. Geological Survey, sampling lava flows in Battle Mountain, Nevada, found evidence for a brief, several-year-long interval during a reversal when the field directly changed by over 50 degrees. So this is coming from USGS as well. Now the reversal was dated to approximately 15 million years ago. In August of 2018, just last year, researchers reported a reversal lasting only 200 years. But a 2019 paper estimated that the most recent reversal, 780,000 years ago, lasted 22,000 years. So the most recent was 22,000 years, but the ones before that were quite fast. Magnetic field will not vanish completely, but many poles might form chaotically in different places during reversal until it stabilizes again. The cause of the magnetic field of the reversal of the Earth and of the magnetic field of the Earth and other planets that have magnetic fields is generated by the dynamo action, in which the convection of molten iron in the planetary core generates electric currents, which in turn give rise to magnetic fields. In simulations of planetary dynamos, reversals often emerge spontaneously from the underlying dynamics. For example, Gary Gatzmeyer and collaborator Paul Roberts of UCLA ran a numerical model of coupling between electromagnetism and fluid dynamics in the Earth's interior. Their simulation reproduced key features of the magnetic field over more than 40,000 years of simulated time, and computer-generated field reversal itself. Global field reversals at irregular intervals might also have been observed in the laboratory liquid metal experiment VKS2. In some simulations, this leads to an instability in which the magnetic field spontaneously flips over into the opposite orientation. This scenario is supported by observations of the solar magnetic field, which undergoes spontaneous reversals every 9 to 12 years. But with the Sun, it is observed that the solar magnetic intensity greatly increases during a reversal, whereas reversals on Earth seem to occur during periods of low field strength. Now, what everybody asks is, what effect does this have on life on Earth? What are the effects on the biosphere? Shortly after the first two magnetic polarity timescales were produced, scientists began exploring the possibility that reversals could be linked to extinctions. Most such proposals rest on the assumption that the Earth's magnetic field would be much weaker during reversals. Possibly the first such hypothesis that high-energy particles trapped in the Van Allen radiation belt could be liberated and bombarding the Earth. The details calculations confirm that if the Earth's dipole field disappeared entirely, leaving the quadrupole and higher components, most of the atmosphere would become accessible to high-energy particles, but would act as a barrier to them, and cosmic ray collisions would produce secondary radiation of barium-10 or chlorine-36. An increase of beryllium-10 was noted in a 2012 German study showing a peak of beryllium-10 in Greenland ice cores during a brief complete reversal 41,000 years ago, which led to the magnetic field strength dropping to an estimated 5% of normal during the reversal. There is evidence that this occurred both during secular variation and during reversals. Another hypothesis by McCormick and Evans assumes that the Earth's field disappears entirely during reversals. They argue that the atmosphere of Mars may have been eroded away by the solar wind because it had no magnetic field to protect it. They predict that ions would be stripped away from Earth's atmosphere above 100 kilometers. However, paleo-intensity measurements show that the magnetic field has not disappeared during reversals. Based on paleo-intensity data for the last 800,000 years, the magnetopause is still estimated to have been about 3 Earth radii during the Brunhes-Matuyama reversal. Even if the internal magnetic field did disappear, the solar wind can induce a magnetic field in the Earth's ionosphere sufficient to shield the surface from energetic particles. Hypotheses have also advanced towards linking reversals to mass extinctions. Many such arguments were based on an apparent periodicity in the rate of reversals, but more careful analysis shows that the reversal record is not periodic. It may be, however, that the ends of supercrons have caused vigorous convection leading to widespread volcanism, and that the subsequent airborne ash is what caused the extinction. So it could be that the reversals caused the volcanism and the volcanism caused the extinction because of course, the volcanic or nuclear winter, because of the ash cloud covering. Tests of correlations between extinctions and reversals are difficult for a number of reasons. Large animals are too scarce in the fossil records for good statistics, so paleontologists have analyzed microfossil extinctions. Even microfossil data can be reliable if there are hiatuses in the fossil record. It can appear that the extinction occurs at the end of a polarity interval when the rest of that polarity interval was simply eroded away. Statistical analysis shows no evidence for a correlation between reversals and extinctions. But reversals do cause volcanism, which cause extinctions. I'll leave links below for you for this. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.